So this event is called Imagination in Action. So let's imagine that the ideas we're hearing about can be a call to action and really permitting action, computational action, not just by the great presenters we heard today, not just by MIT researchers and researchers in other companies, not even just by students who are studying computer science, but by everyone, even kids in elementary school, and all over the world, even in the poorest communities. Let's imagine a world like that. And we don't have to imagine it because that is what's happening now. For example, some of you know that Dharavi is one of the largest slums in India outside of Mumbai. It has about 1 million people. Average income's about $50 a month. And Dharavi is also home to the tech girls who are using this technology to make things for their community. Right? So these are girls who are I think 13 to 16 or something, who are making things that really are about improving the lives of the people around them. They've built an app using MIT App Inventor called Pani, water, and what it does, it schedules your family's time at the community water distribution plant. So you don't have to go and wait in line, things, you don't have to go and have fights. This is really meaningful to those girls because you know who the family is going to be sending to the water distribution plant to be involved in the fights, right? But this is real getting their hands on, for their vision of the world, what would improve their lives and the lives of the people around them. And we don't have to imagine. Let's imagine a world where everyone can do that. And that's where we are now. Here's another, right? This is computational action because it says that people, even in the poorest communities, can create tools to improve the lives of the people around them. That is a consequence of the technology that we are all creating right now. Another example is Moldova, right, which of course is having tremendous problems from Russia right now. Another problem that Moldova has is hepatitis B, because it's hard to find sources of good water. So there's a group of, I think, 6 high school students in Moldova who have made an app, that allows you to find good water. You go to a source of water, you take a picture of it with your mobile phone. You fill out some kind of rating. You write some comment like, oh, the pump handle at this place is broken. And then what they've done with this app is they've put it up on Google Maps. So what it means that anybody driving around in Moldova, anyone in the world, can go find this database if they're looking for pure water. Right? And this is another example of computational action. Apapura means good water. And it says even children can create resources that have a nationwide scope. And the main message I want to make to you is we're not thinking like that. We keep talking about, democratization, where we mean maybe lots of companies can do it and lots of places can do it, but we don't think of this technology as democratizing the opportunity for everyone, even including kids. And the main message I'd like to bring you is that is the world we are living in right now. And it's the way we ought to be thinking about when we think about the implications of this technology that we're building. Another one closer to home this is Anjali Rao, who was inspired by the awful stuff that was happening in Flint, Michigan with the water, with the air. And she said, why can't we make something like that about the water? So she built a little sensor thing that senses pollution in the water, and then built an app. And we're really proud of her because she was chosen as Time Magazine Kid Entrepreneur of the Year couple of years ago. Here she is. Here she is on the Jimmy Fallon show in 2018, and she's actually explaining to Jimmy Fallon how her thing works, and then it hooks up to an app. And Jimmy Fallon says, and she said, I created this app, turning out using MIT App Inventor. I created this app for Android phones, and Jimmy Fallon says, you're 12 years old, and you did that? Well, that was in 2018. Anjali's not 12 years old anymore, but in fact, she's just finishing her freshman year at MIT. Let's see. Anjali, you here? Hey, let's wave. Stand up and wave to people. Okay. Okay. So this, of course, is very special, but it's the kind of thing that's really open by this platform we call, it's called App Inventor. What is App Inventor? Well, it's an open source platform that allows anyone, and I really mean anyone, to create mobile apps. And a lot of stuff that we're doing has to do with accessibility and for under-resourced populations. We're doing a lot of work in the developing world. It was started at Google, and then Google transferred it here to CSAIL at MIT. And I think we launched it in 2011. And the goal is to really help everyone make effective change in their communities. Let me show you an example of what it is, just very, very quickly. Here's, you sit at a web browser and you're doing things. The web browser is connected to a phone, which you see over there on the right. There's a real-time live connection between what you're typing and a phone. And in this one, what you've done is you've dragged onto that screen to say, let's put a button in my app, and let's actually add a sound to that button, which is an example of a cat meowing, and let's actually add an image that makes the button look like a cat. Okay, at this moment, I have a working app. Right at this moment on the phone there's a working app there that basically has a button that looks like a cat. Of course, it doesn't do anything. We haven't told it to do anything. We have to actually put in the code that says do something. So if you come over here to what we call the block screen, you see a block, that green one that says, what are all the things that a button can do when it is clicked? And then we've added into there, when the button is clicked, you play the sound of the cat meowing, and you also, on a label on the phone, show the address of where you are. Okay, let me stress. At this moment, we have built a complete working app. That's what it takes. And that's the beginning of the kind of stuff that in the examples you just saw that I gave, that's the kind of platform that everyone can use to build things that unleash their imagination about what is wrong. Okay. We're running a server here at CSAIL. Here's the activity on it. From our little research group at CSAIL, we are hosting 1.4 users a month. Right, so that's kind of running upstairs here. 350,000 weekly and about 60,000 daily, but of course it fluctuates. And here you see what it looks like around the world. We're in 185 countries. About a quarter of those is the United States. A very large place. There's a lot of stuff in Latin America, and it's growing very, very fast. Right, it's 100% growth of our use in Latin America over the last year. And some places really into it. So 75% of the school kids in Hong Kong are using this. So it's a large thing we're doing here from CSAIL. The impact is, in the year, this is for the year, there are 9.2 million people using it this year, 195 countries, and 47%, almost half, from the developing world. So this is not a special thing for the rich countries. What we really care about, and when we talk about democratization, we really mean everybody, and it's really happening. And you see the growth has gone up a lot over the last year. One of the things that's sponsoring that growth, of course, is AI. So it's become much, much more visible. And of course, we have things where kids can build things with AI, not just sort of using AI thing, which is important too, but kicking to build things with AI. Here's an interesting video that lets them actually create voices and actually create for themselves to create deep fakes so they can start understanding what that whole situation is like with misinformation. They can understand it because they can build it for themselves. Here's another example. This is what we use in our very introductory work with middle school kids. That says, can you build an image classifier? Can you build an app that when you show it your face, the baby smiles, and when it's not looking at your face, the baby cries? So that is a first exercise that you can do in starting to use AI to build things. Of course, the next thing that's coming on is everyone's talking to chatbots. So of course, we can make things where kids can talk to chatbots. They can build their own app that talks to things like GPT-4 and Meta and all of these things. I'm showing you what it looks like on the screen, and there on the left is the actual code that you have to write if you want to be doing something with a chatbot. So if you want to think about those things, it basically says when you click the button, call the speech recognizer to recognize what you say. And when the speech recognizer comes back with something, take that and pass it to the chatbot. And then when the chatbot comes back with something, pass it to the phone to speak what it says. Okay, so there are lots of things like that, but the point I want to make is this is what a kid needs to do to implement that kind of feature in the App Inventor platform.
Hal, do you want to have someone do a demo?
I'll do a demo in a minute. And I just want to say the other thing we're doing is we're working with Amazon to make not only apps, but Alexa skills. And there you see a picture of what it's like to make an Alexa skill. What's next? If this isn't easy enough, the question is, let's imagine again. Let's imagine that instead of playing with those blocks on the screen or something, you can just speak what you would like, and the system will create an app that does that. And again, we don't have to imagine that, because Evan's here is going to demonstrate the work our group is doing to make it real. Evan. Okay.
All right, thank you, Hal. So this is our project called Aptly. It's App Inventor, as Hal was discussing earlier, enhanced with generative AI. And I'm just going to make a very simple app quickly to show you how it works. And this is a live demo, so we'll see how it goes. So I'm going to say create an app that will allow us to vote on real pi or mathematical pi. And then I'm going to click code it, and this is going to take our textual representation and give a bunch of example applications that have been built, and send that off to one of the large language models that are out there in the world. And then it's going to come back and try to give us some code. And so here's the code that it's created. And we can go and we can turn that into an app. And so this is the app it came up with. It's got a couple labels. It's got a couple buttons. If we go over to the blocks, we can see this is the code. So we have that here, and we can actually go ahead and we can look at what that looks like on our phone here. And then I can say we can vote for real pi, and the counter goes up, and we're at MIT, so let's try to have a lot more mathematical pi in our world. There we go. And then we can, as Hal was talking about, play around a little bit more with generative AI. So I'm going to come in here. I'm going to grab our chatbot, and then I'm going to give it some instructions. Use the chatbot to give a humorous example of why the winner won. And then it's going to go off, and it's going to take our existing app along with that description, and it's going to try to come up with an example of how that might work. And this process can take some time, unfortunately. It is real time. But it's really neat because now you can start to think of having a vision of what app you'd like to be building. And even if you don't necessarily know how to put together that in a very complicated structure, the AI can help assist you. And so maybe I didn't know how to use the chatbot, so now I can come back here and I can look at the blocks, and we do have to do a little cleanup because it's not quite spatially aware yet. And then we have, it uses this converse block, and so let's vote for our pie again and say get winner. And then it's going to go ask the large language model, here are our votes, and it's going to come back with an example. And again, we're using a remote service, so it can take a little bit of time. And when it does it, it should put it in a label down here. Oh, well, it's not happy with me today. That's OK. But the idea here really is that you can, with very limited skills in terms of programming, start to really build applications that can have real-world value. And you've seen some of those examples in Hal's talk.
All right. Great.